Hello, welcome to day 2. We're going to start to investigate graphing logarithms. So yesterday we introduced logarithms. Logarithms, remember, are the inverse of exponential functions. And so when we are graphing, we can use some of the patterns we saw when we started talking about inverses back in chapter 6. First of all, a exponential is y equals b raised to the x power. So our base b, our x, our input of our function is going to be in the exponent position. And the inverse of that would be y equals log base b. Remember, the base of your log equates to the base of your exponential, log base b of x. So to get this red function over here, the log base b of x, what we did was we could switch the x and the y, like we talked about in chapter 6 with inverses, switch around the x and the y. And then to solve for the y, to solve for that exponent, we are going to rewrite it in log form. So our log form and our exponential form are inverses of each other. So to start graphing a log function, we really are going to start by looking at the exponential function. So here we have y equals 2 to the x, and we'll just look for a couple of inputs, outputs, 0, 1, 2. So when we put a negative 2 in, we'll get 1/4. Put a negative 1 in, we'll get 1/2. Sorry, I'm getting kind of small. Put a 0 in, we'll get a 1. Put a 1 in, we'll get a 2. Put a 2 in, we'll get a 4. So we've got some inputs, outputs. 1/4, I'll just kind of estimate that's going to be about right there. 1/2, 1, 2, and 4. So there's kind of our picture of our exponential. So we can see our exponential. It's got the asymptote happening right at the x-axis, y equals 0. And then also we have a b value that's greater than 1. We can start to see that growth happening. Now the logarithm y equals log base 2 of x is going to be the exact inverse of y equals 2 to the x. So to find x and y pairs of log base 2 of x, we are simply just going to invert the x and the y. So all the y coordinates of the exponential form become the x coordinates of the log form, and then all the x coordinates become the y coordinates. So a log is just simply a inverse of the exponential with the same base, and we can find the exponential inputs and outputs, and then the log will just be those x and y's inverted. So now when we're graphing our x, we're going 1/4, so that's just going to be to the right 1/4 down -2, to the right 1/2 down 1, 1, 0. We'll go 2, 1, and then 4, 2. So our logarithm is going to start to get closer and closer to that y-axis as your x approaches 0. So as your x approaches 0, this graph is going to keep getting closer and closer and closer to that graph. So we have an asymptote for the logarithm. The asymptote is going to be the y-axis. So your asymptote is x equals 0, which is also known as the y-axis. So there we have it. There would be our log graph, and we can start by investigating what the exponential graph looks like. So there's going to be a couple different ways that we can graph these logarithms. We can graph logarithms using technology, or we can graph the exponential version of the logarithm, and then we can flip around those x and y values. So we'll continue talking more about that in our first problem, taking a look at example 4. So here we have y equals the log base 6 of x. So first I will show how to graph using the exponential form. So this y equals log 6x comes from the inverse y equals 6 to the x. So we can start by looking at the input-output pairs of y equals 6 to the x. And with exponentials, it works best just to go -2 to 2. Exponentials accept all x values, so negatives and positives. You'll find out that logs do not accept negatives, so you'll see that if you try to do that. Anyway, we'll take -2, we put it in, that's going to be 1/36. -1, put it in, that's going to be 1/6. 0 will give me a 1, 6, 36. Then the log base 6 of x is going to be the inverse of that. So simply just take all of those x and y values you just found, and you will reverse them. So the x's now are the y coordinates, and the y's are the x coordinates, -2, -1, 0, 1, and 2. Then we can head over to our graph, and we can graph that out. Second thing we can do is we can graph using graphing technology. A nice program to use is Desmos, and if you watch the Delta Math videos, you will see that Desmos is often used for representing those graphs as well. If you look at your schedule, just that green icon there, you can open up, click on that. That'll open up a tab for Desmos. So here we have y equals 6 to the x. So we could find a couple of points. Delta Math is going to look for nice whole number coordinates. So here we've got 1, 6. We've got 1, 0, 1. So those are some x and y coordinates that we could reverse because we're talking about the inverse. Second thing you could do is you could actually graph a logarithm on Desmos. So if you hit y equals, then you go to this functions, miscellaneous, and you head down to the kind of second row from the bottom. We got log, and then there's a little a there. It's kind of hard to see, but you hit log a, and then you'll be able to put in your base 6, and then in the parentheses you'll put your x, and then if there was any type of h value or k value, you could put that in with the x in there. But there again, there would be our log function. So you could go and grab a couple of points here. So 1, 0 is one of our points, and 6, 1 is one of our points. And you'll find that a lot of the xy coordinates are going to be decimals. So we head back. We'll choose these 2 points again. So we'll graph this one, 1, 0, and we'll graph this one, 6, 1. So 1, 0 is right here. 6, 1 is right there. And then also paying attention to where the asymptote is. And logarithms are going to have vertical asymptotes, where in section 2 you practiced exponentials, horizontal asymptotes, but we'll have a vertical asymptote for the logarithm. And then you'll be able to select that on your Delta Math. And we'll practice one here in just a second too. All right, so there it is. So there's our logarithm graph. So you'll find out that they're a little messy with the decimals and things, but you can do it one of those 2 ways. You can graph by hand by using the exponential form and then flipping around all your x's and y's, or you can go into Desmos. And if you forgot what I did, just rewind the video a little bit and you'll be able to find out how to do that. Next, we'll talk about our family of log functions, and this is going to be ultimately the same as all the functions we've talked about. So our stretch happens when a is greater than 1. So if we start to see an a value out in front of our log, and just to back up a little bit, I'm just using the parent function y equals log x. Remember, this would have a base of 10. It's a common logarithm. But whatever the base of your logarithm is would apply then to the base for all of these functions that we're looking over right now. If you're between 0 and 1, that's going to be a compression. Your h is going to move you left and right. So minus h moves you to the right, plus h moves you to the left, and your k value moves you up and down. So plus k is up, minus k is down. And here we have y equals a log x minus h plus k. So heading down to our example here, how does the graph compare to the parent function? So first of all, our parent function would be y equals log x. So now we're just going to look at what are we starting to add in. So it looks like our a is equal to 3/4. So if a is 3/4, that's going to be a compression. And secondly, we have a -2 for our k. So that's going to be a k is equal to -2. And that's going to mean that we are moving down 2. So those are our 2 transformations that are happening with this function. One thing I just realizing that I don't have in my table up there is if a is negative, that's going to be a reflection. And that's something we've talked about before. Nothing new. That'll be happening with logarithms as well. So that recaps how to graph logarithms. So you can use the Desmos graphing technology, or you can use the exponential form and then look at switching your x's and your y's. We are now going to take a look at an example problem from your Delta Math assignment. So here would be an example of graphing a logarithm. So I will show you a couple ways that we can graph this. So first, we have f of x equals 3 log 5 x plus 1. So some things that I can tell right away is that it's going to be a stretch of 3 because that a value is 3. No reflections, not negative, and then plus 1 means it's going to be shifted up 1. So first thing we can do is we can find the exponential version of this. So x equals 3 log base 5 of y plus 1. And now we're going to go back and solve for y. And really, I'm focused on getting this log alone, because once I get a log alone, I'll be able to start solving for that y. So here's where we're bringing some of the patterns from chapter 6. When you need to find an inverse, which we're going to find the exponential version of this, then we can start graphing the logarithm after. So I'm just going to undo, I'm going to subtract 1 to the other side, subtract 1. So we get x minus 1 equals log 5y. Oops, forgot the 3 in front. Okay, then we'll take everything, divide by 3. Divide by 3, so we got x minus 1 over 3 equals log 5y. Okay, now is where we can convert this into an exponential. So remember our exponential, we talked about in day 1, b to the y equals x. That's going to transfer into log base b of x equals y. So there's where we're in our logarithm form, we're going to transfer it back into exponential form. So my base is going to be 5. My exponent is going to be x minus 1 over 3. Remember, log solve for exponents. So this thing right here, that's your exponent, equals y. So there I'm back into exponential form. So one way you can do this is you can graph the exponential form and then just flip around your x's and y's. So we'll head to Desmos and we'll put that first one in. So in the purple here, we'd have that exponential that we just created from the log. And you could pick out a couple of points, like I was just looking at it. You could pick out 1, 1. So there's an xy. So that would also be 1, 1 as the log because they're just flipping the x and the y. And then you could also pick this one right here, 4, 5. So that would be 5, 4 when we do the log. So one way is to graph the exponential, and then you just reverse a couple of those coordinates that you know to the other direction. So this would be 5, 4. The other one would still be 1, 1 because they're the same both ways. But you could also just graph the log. So there's my log right there. So I just used, remember on that keyboard, you can go to functions and then miscellaneous, and then you can type in your log. And then you'd find a couple of points that you know are nice whole numbers. So there's your 1, 1. And there's your 5, 4. And that was also from your exponential, that was a 4, 5, but we just reversed it the other direction. So there's your exponential, there's your log, so on and so forth. So some other things to pay attention to on your log, this one is going to have a vertical asymptote at 0, and then we'll graph the point 1, 1 and 5, 4. So we'll go do that now. So back at Delta Math, we'll go ahead and select a vertical. We'll slide that over to 0, 0. I got to get these points moved here. So one of my points will be 1, 1, should slide in there. And then another point is going to be 4, 5, and it should slide into there. I'm just going to double check. Yes, 4, dang it, 5, 4 is what I should have had. So I'll go back here. 5, 4 is going to be right there, and it should kind of slide in there. And there it is. So you can convert it to exponential form if you like to see what the exponential form is, but you can also use Desmos to put in the logarithmic form. Once you have that log form in, identify where that vertical asymptote is, and then you'll be able to start to find two coordinates that you know. Let's see how we do. There it is, and then they'll give you a quick rundown. Looks like our graph, they chose the same points as us, and there is our solution. So you got a couple of options on how to do that, but you are ready to start practicing. You got 4 log graphs to try out. Play around with Desmos, check it out, and see all the different things you can do on there. It's pretty cool. All right, have a great day, and we'll see you next time.